So if you guys have any question, just call my attention or message on the chat box. So I'm not always looking at the chat box. I might not see it immediately, but that's okay. So yeah, a quick short recap of what we did last week. We were trying to access a website. Now, where was that website? It's booksthescrape.com. All right, this is the one. So again, our goal was to get all the information of every book in every category of this entire site. Okay, so basically you have the entire collection in one spreadsheet. That's what you want to kind of get all the data, see what you can get out of it, right? Um, Again, the real goal here is the web scraping part, not the uh, using our algorithms part, right? So it's the acquiring of data. So we are using uh Visual Soup, right? Pygol time. We were exploring the how do I call this one? Developer tools here and look for some example here in the networks for our headers, right? For example, of our headers, that's somewhere around here at the bottom. Here, you can just copy that one. As the user agent, put that here. You guys remember. User agent is just one of the headers. If you take a look at it here, headers, there's a lot of things here that you can put. User agent is just one of them. If you want to modify it further, you can put all these other things, but it's not really necessary at this point. Okay, usually the request method once it doesn't need plugins or something like that. It's just uh directly available for us to get. So that's why there's no need to do all the other things, just the user agent. Next is we define how to get the data. So we try to analyze the HTML of the site. And instead of opening up each book like this and getting all the data, we just get so again the necessary data is what the name, the price, the in stock, and the number of stars for that book or the review. So it happens that those data um, is also available here on this page. Okay, so this is actually much better since we can see all the books. We don't have to keep a list of a lot of links for each book. So in this one link, for example, travel, we can get all the books related to travel directly, and then um, get the data for each book, since these are the only four that we are looking for, right? Of course, you can try and look for more if you want, but you'd have to get the link for each book, go inside of each link, and then you have to analyze the HTML of this page next, and then get the data you want. Like, for example, the UPC, um, what else? Tax, if there's tax, and what else? So there's also a description, yep, if you want. Yeah, that's pretty much the only thing that you can get here. Taxes, I think pretty much everything is the same. But the point here is that can you extract those things, right? It's not about the data itself. It's the way of extracting the data, all right? So again, if you want to challenge yourself, you can do that. So here, we found out that this entire thing is just a bunch of list items like this one. And then we discovered that all of them have similar classes, right? This one. So the odds of anything in this page that have these similar classes existing in other parts of the page is very low. So we can be pretty much sure that if we use this one as our search criteria, we can get all the loops that we want. That's what we got here. And then we created just a simple loop, right? Simple loop that accesses that data, right? This item in the HTML. And then if you look inside further, you can get all the data that you need, which is in this case, we have the star rating. So it's using actually a class as the way to tell whether how many stars there are or not. So if this is three instead, there will be three stars. So it's using classes instead of an actual number. So yeah, as you can see, it's just a bunch of images. So the eye does images, and then each one will just be colored differently depending on the class that you put here. So the one we're trying to get is the class two. What else? We have the title here. It's under the H3, the product price. It's under the product price, and also the availability here. So we need to just get those classes. So we have star rating, get class -1. So this is since this will return a list. If we say -1, it will automatically get the last class from that list. So that's why what we get here is um whatever is indicated here. Yeah. Title, you can just go for H3 and then find A, get title. That's what it looks like here, right? H3, find A, and then it's in the title description, in the title attribute, or you can also get the dot text if you want. Either way, you will get the same data. Price, it's in the price color. Price color, yes, it's under the price color, and then you get the dot text. That text get or the get text method is also useful just to make sure that there are no extra spaces before and after. That's what the strip attribute is for. Strip, yeah. And then availability is what is stock availability. It's over here. And then, yeah, in stock. That's what you're trying to get. All right, and then after that, just get all of those data, put them into one big object, books in this case, put some proper subjects for each one, or keys in this case, since we're talking about objects, and then append everything into one big list. All right, so we're gonna append the entire thing into one big list so that we can return them as is a big list. So return data. So um we'll be returning a list of objects, and each object is a complete collection of data for that book. Okay. So here are all the URL segments that I prepared beforehand last time. These are the links. Okay, this is one way to get all the links for each URL. So this is manually done. It's pretty easy because it's not really that much. So you can do this manually, or you can do this programmatically, right? And then how do you do that? If you want to know, so you can just look for, instead of looking for these things, you can look for um the things here on the side. Okay. So here on the div, there's another UL list, UL. All right. So these are all the things that are indicated. See, whenever I point my mouse there, it's also highlighted at the top. All right. So that means that element corresponds to that section of the web page. And if I click on here, you will see an anchor tag and also a let's see, anchor tag right here. travel. So currently travel is saying index because this is where we are currently at. So if I go to mystery, right? Let's see. Mystery now will say index.html. See? So you have to be careful of this one. The safest way is to go to books. And then in this part, you will get to see the actual link. All right. So you might be confused. It's not the complete link. Yes, it's not a complete link because what you need to do is to combine the base URL and this URL. All right. So if you click on travel, see this is the base URL. All right. And then this is the uh catalog and category. So you need to add these things too before adding these. So let's see. Yeah. So you need to add catalog and category in this case. So it's not just the base URL. You need to add these two. And then what you need to save is this thing. And later on, you combine each of these, each of these things that you scrape into one URL and then save that to another list. And you need to create another function that will access those things one by one, similar to how we are doing here, right? If you remember, we defined this function and we had a book URL here. We will pass the URL of each category here. We'll access it, and then afterwards it will get all the data. Okay, so that's why I just opted here to just um, write it manually since it's not really that many. Okay. After that, let's see. Oh yeah, this is the part where we swapped out this URL with the insert here. Swap this part here to this one for each category. And then all genre info. This is the part where we are using the function that we made above together with all the URLs that we generated in order to access all the data. All right. So now it's in here, all genre info, everything, all our data is stored here. So we printed out all genre info travel, for example, because that's what we did here, right? Travel. Okay. Um, yeah, and then we're using, let's see, all genre URLs. Where's the part that we say that it was named travel? Okay, here it's all genre info and then genre. So when we were accessing the all genre URL items, it was named these things on the left, the keys. So we just passed them over to all genre info to this object, and that's why we could just access them like this one. And if you take a look at our print statement here, you can clearly see that it's a list of objects. So each object is a book. And if you compare it, so the first one is the title is It's Only in the Himalayas, 45, star rating of 2, and availability is in stock. That's exactly what we see here also. And the first one. And the last book here is 1,000 Places to See Before You Die, 26, 5 in stock. That's what we have here. 1,000 places, 26 in stock, 5 stars. Okay. So this is where we at uh, right now. Okay. All right. So the next part that we're gonna do is, let's see, we're gonna count the star for each rating. So let's see how are we gonna do that. let's count the stars for each ray. So let's save this one in a another object. So let's say genre underscore things. All right. And then we're going to create a loop over all the information that we have. So we already have this one available, right? So for, wait. I'll put it all in the same cell. I'll remove this one for now. Okay. So for genre, so we have the genre and we have the books, which genre in all genre underscore info. And then we're going to use items here to get each object. And then let's see. We're going to create a object here called ratings. And let's see. Uh, five. How many fives are there? So it's important that I match what the class is for these ratings because that's how we saved it before, right? We did not convert it into a number. We saved it as how it's indicated here in the HTML. So if it was indicated as, let's look for a 5 star or 4, maybe this one, it's indicated as 4 with a capital F. So we have to do that same thing here below. We're going to use a capital F, all right? Because that's how we decided to get the data. We did not convert this word into its number equivalent. All right, so this is also 0. We have 3. This is also 0. We have 2. This is also 0. And we have 1. It's also 0. These are all zeros because we're still starting out. We haven't counted anything yet. All right. Uh, After that, let's see. Books here, if you remember, right? This entire thing is a list of books. So we need to create another loop inside of this loop to access each book. So we're going to have to say something like for book in books, right? We say books because this is what we use here, books at the top. So for book in books, so for book in books, we'll say ratings of book. All right. No, wait. Book. We're accessing the book and we're accessing the star rating, right? Because that's how we saved it here. Star rating. We called it star rating. Okay. So it's very handy sometimes that you keep like a notepad or a handbook on your table or somewhere on your screen that um takes note of the important objects in your program so that it's easier to remember what you need to access. So here we say it's star rating and then book star rating and then okay, star rating and then so depending on what we're trying to get, if it says 2, we need to increase this number by 1. So all we have to do is return the exact thing, but add one more to it. So that's exactly it. That's all we need to do. So for each book, it's gonna scan each book. It's gonna um, read the star rating key value pair. And depending on what the star rating is, it will automatically adjust here to which one it matches. So if it's three, it will go three, four. So it will keep on adding one to these readings. And then after that, let's see, we have genre ratings, and then we'll add genre here because we're trying to get all the stars for that genre. Okay, so ratings, right? So this is for the travel, for example. So genre ratings travel, these are the ratings for the uh, travel category. So we'll see how many books are rated 5 stars, how many books are three, how many are two, and so on and so forth. So we kind of just consolidated our data that's already available here into something that's more precise, right? That we can maybe use it somewhere in our uh, project. All right. What comes next? So we scanned all the stars, right? Um, okay. Let's also add for all the books. Let's try all the books. So what? We have one for each category. Let's try and see this one, what it looks like for now. Print genre ratings. Hmm. It's still loading. So the next thing that we can do with this is we can add all the ratings of all the genres. So that way you can kind of look at the bigger picture in terms of ratings. You can take a look at all the 5 stars in different categories as well. So you have two choices. Either it's consolidated into one big um, rating object or divided further into each category. So yeah, we have two options. So we should see here a list of all our categories. And then for each category, we should also see an object similar to ratings showing how many books are for each rating. There are for each rating. Okay. So it's actually taking quite a while. It's a pretty big collection. Right. So here we are. Um, so as you can see, each category with an object as a value. And you can see that on the travel, we have how many books? One, three, six, nine, 11. How many books are there here? 3, 6, 9, 11. So it's correct. The number, the numbers indicated here indicates the number of books they have on the site, which matches what we have here. So as you can see, we have three books that are 3 stars, three books that are 2 stars, and so on and so forth. So all these other things are for the other categories, right? You can manually select one by using the uh, brackets here to select individual key value pairs if you want. Like if you want to select travel, you can do that here, but we're not going to do that. Okay. So let's just add one more step by adding everything into one big list. So I'll start ratings. This will still be the same with this. Actually. All right. Um, okay. So we have all the ratings now. We're gonna loop over each one, genre and ratings. And genre underscore ratings dot items. So pretty much the same thing. Oh no, wait, yeah, we're accessing this one now. All we have to do is add the things that matches. So since for each category, it's another object, we're gonna need another for rating in count in ratings dot items. Rating count. Yep. So we're accessing 5, 4, 3, 2, 1, and then rating and count. Getting the value and save it to count, and then add that count into our all-star ratings. Rating, and then plus equals to count. So if we have 5 here, right? Travel 5, and then go directly to mystery afterwards, 5 of 3. So 3 will be added to 5. So now in the all-star ratings, it will become 4. So basically all the 5s are added, all the 4s are added, and you get the whole collection. An overview of the whole collection in that website. All right. I think there's no need to actually show this one. It's just a single uh it's just a single object, right? You can just see the whole list of books that are these uh 5 stars, 4 stars, and so on and so forth. Okay. So any questions so far or clarifications? So we've been doing some multiple for loops here in this part. So I hope you guys still manage to follow the sequence, right? Like what data we're trying to access at which point and why we are using these specific lanes. Okay, so any questions so far? All right, so I'll take that as a note and I'll continue. Okay, right. Okay. What else can we get from this data? So since we have all the books, all the ratings of the books, we can also get the total number of books, right? So you can say genre for each genre. book counts. So we can know uh which categories they actually prefer to have in stock. So that's also a reflection of what are the buyers actually looking for usually in the website. Items. All right. So journal info books, all journal info items. So it's just as simple as using length. You can use length and then books because books here, if you remember, all genre info at the top lists all the uh, books that we have, but yeah, it's in per category at this point. So that's why you're trying to access per genre, okay? And then, yeah, okay. So you can just go directly and say length of books because we are accessing each key value pair, correct, correct. So this actually works. Next thing that we need to do is to add the books that are counted to our new object, book counts, that specific genre, whatever that genre is at this point in the loop, and then add whatever the count is. Okay, so now we have all the counts. We can just get the total book count, supposed to sum genre for book counts dot values. Okay, so sum is a special function that we can use. Values will give out all the values in a list format, and then it will just add everything in that list and give us a total and save it to our total book count. All right. We can print this out later, but for now, since it actually takes a while, right, to actually run the whole thing, we can skip that part right now. All right. What else? Okay. I guess we'll go ahead and yeah, show our graphs. Let's show this things into our graphs. So if we say, since we're using, what are we using? Since we're using Pygal here, so I hope you guys have installed Pygal as well. Um, so bar chart is equals to Pygal dot horizontal bar, and then bar chart, another annual book review, uh, star distribution. Okay. Next is we'll add the data to the chart. So for rating, uh, rating and count in all star ratings items. And then we'll add bar chart, add method. And we are accessing each rating and the value that it has. Okay. So if we put this one into a chart, bar underscore chart, render, and then call on display to display the SVG chart, and that should be it. Um, so this is just basically one big chart that we will see when we run this code later on. Let's actually uh, put the print statement here. The print genre. Wait, let's put in a total number of books, and then yeah, let's print that one here so that we can see the output later on. Um, this one we'll also see it later on when we run it. What else can we get? Um, let's try adding a chart for, let's see. So this is for the ratings, right? If we get the one for each, let's say each jog, right? Uh, we can go ahead and just copy this entire thing. We'll give it a different name by jog. Per rating count, this time we're gonna be accessing genre counts underscore counts dot items that add rating and count render. All right. Okay. So that will be a different chart as well. I think it's better if we separate. So the difference is if I were to run everything, if I trigger an error in other areas like this one, it would be nice if I can run this one. All right, let's try it. I'll separate this one into a different cell, and this one as well into a different cell. That way we can see the outputs separated by each cell, so it's not really that messy to look at. Okay, there. And then one last chart, we'll add one last chart. This time we'll use a pie chart. So pie chart is equals to pie and then pie underscore chart dot pie. We'll name this one distribution of books across genres. We're gonna have a loop genre of count in genre underscore book counts dot items, and then add this one to the pie chart and genre count. Uh, chart is equals to I underscore chart dot render, and then something pass this one to display SVG chart. All right, so hopefully I did not make any um errors in my spelling. General count. Okay. All right. So when we run this one, we'll start here. When this is ran, um, only after this is ran can we also run the other part of the other cells so that will show their data. Okay. So let's start running this one. The only thing that we will see here is the total number of books from the genre book counts. So yeah, let's run this one. Okay. So this is the only part that takes long. Once it's loaded, we have access to the data, um, and also the new process data. Then we can go ahead and proceed to the other parts, and it should not take long because the data is already stored in memory in our local device. So that's the handy part about web scraping because once you get the data, you can actually just stop there, get the data, and then save it into a CSV file or a other formats that you might prefer, and then use that one, load it to another program, right? And then process that one instead of always trying to access uh, the site because it actually takes quite a while. Because what you're trying to do here when you're web scraping is you're trying to emulate that the program is a person trying to access a website and then it's just getting some data. If you try to access it real quickly, the servers will detect that and they will stop you from accessing it. The worst case that can happen is they will block your IP, so you cannot access it anymore using your ISP connection. You have to go to a different connection. And yeah, whenever you're scraping data, make sure that it's really public, right? Like if it's visible for everyone, that means it's public, and also it's not something that is protected by intellectual properties like arts, research papers, and so on and so forth. So other than that, everything is fair play. So yeah, it's still loading. Let's just wait. In terms of what library to use for, no, ratings, 139, view, show light numbers, 139, all-star ratings, forgot again, all-star ratings, ratings, okay, all-star rating, all right. In terms of the library, on what library to use for visualizations or your charts, it doesn't really matter what you choose, whether it's Pygol, Matplotlib, or any other library. What's important is that you are able to show the data, right? And then the audience, your target audience, will also be able to understand what you're trying to show them, right? That's the important. So It doesn't really matter what you use, but there are some uh minimal things that you must have, the library must have before actually use it. So it must be it must have a community. So that's really important because uh it's in the community where you can actually ask questions when you encounter problems. So odds are your problem, right? If you have one, someone else probably had that one before as well. And the solution will be recorded in the community forums. If it's not there, then it might be in the Stack Overflow website. So other than that, if you're using an obscure library with very few users, then you have to do everything yourself. You have to fix, analyze, and debug the entire code base in order for it to work on your end. So that's just more work that's really not anymore part of our work as a data scientist, right? We focus on the data. Let's not focus too much on the coding part, right? So while rating, can I ask you guys how is it so far? For you, is it do you think you can do this one? You can like shift directly to this what they did. I was starting so I did that one. Even Dict and hashable. What is this error? 159 all-star rating. I'm accessing the value of all-star ratings. Actual dictionary. Hey, give me a moment, guys. I'm gonna try to debug this one. I'm not really sure why it's showing this error. Unhashing. Okay, I see. I'm accessing the wrong one. Should just be rating. There you go. So just a simple letter and automatically gives us an error, right? Okay, that should be it, hopefully. All right, so back to my question. How are you guys doing with data science as an alternative for like uh can you switch to this type of work or you find it difficult? Let me know. Thank you for that feedback, Sir James. All right. So again, you don't have to like go gung ho into this immediately, right? After this course, you can just take it easy and then just do it one thing at a time. Um, Programming is actually very, very difficult. It's very difficult to do, especially because it's kind of it doesn't align with how much like you can learn the language in a day, right? You can get all the functions for that language in a day. You can be familiarized with it, but in terms of using it, right? Like what are its capabilities? How far can you go? That part is actually very difficult, especially when you get to reading libraries like uh I don't know if I've shown you guys. Okay, it's here, but let me just show you first. Beautiful scene. Oh, sure. All right, but this is is it Chromium or that's not the one. Ah, it's this one. The hard part really is when you're reading documentation because you have to read the whole thing. This is the beautiful soup documentation. If you ever wanted to learn by yourself, right? If you wanted to learn by yourself, which is almost always going to be like that in this work, in any kind of programming work, they're gonna give you like, hey, we're gonna use a different library. We're gonna use this one. So like they'll give you a few days to a week to try all of the features that it has, how to use it, how to run it, and then just go over the entire documentation like this. So go over it one by one, and it's actually pretty long as you can see. So that's why I said it's almost always going to be more reading than more coding. And it's one thing if the documentation is written really well, right? It's another thing if it's poorly written. It's not uh, very easily digestible, if you understand. So it's very hard if you end up in your work that you're going to be using that kind of library. But the odds of that happening is not really that common. Usually, companies would default to using libraries that have a lot of users or has a community with it. So yeah, but it still has a lot of work. You still have to be familiar with it, and then there comes the applying it to your work, right? Applying it to your work. How are you gonna use it? And yeah, this is just a constant. thing that happens in programming in any kind of discipline, whether it's web dev, game, data science, that always happens. There's always going to be new tech, and you're always going to be shifting different libraries, different frameworks. Now, frameworks is another thing. It's an entirely different thing because in libraries, you get to decide um, like what to put, right? In frameworks, you have to adapt to that framework, right? You have to change the way you program according to that framework, which is um, a different challenge in and of itself. So if you hear someone saying React, those kinds of things, it's you're gonna have to program it a little bit differently, which takes time actually getting used to. Uh, so yeah, just a bit of information. All right, so here we have the total number of books. So we have Travel 11, Mystery 20, and as you can see, it just prints out each category and the number of books for each category. All right, plain and simple. The error earlier was I was accessing genre ratings items, putting them into genre ratings, and then accessing ratings items and them to rating and count. But I was actually putting ratings here with an S instead of just rating. So you have to be aware of that whenever you're trying to make loops. A good rule of thumb whenever you're dealing with these kinds of things like inner loops, all right, or if in the cases of if statements, the maximum that you should be going below or going down is 3. So if I have another for loop here and another for loop, that should be like your maximum. Because at that point, when you're that far off into the for loop, um, maybe you can alter something else in your program. Maybe the way that you store the data, the way that you arrange the data to avoid these kinds of things. Because for loops are very the loops in general are very taxing for the computer, right? So the more loops that you have, the longer it will take for it to run, and the more inefficient your program will be. So try to avoid this one. Try to stick um, to at least 3, maximum of 3. Um, 3 nests. So we call this one nesting in whether it's for loops or if then else. Okay, anything, any kind of nesting, a maximum of 3. All right, that's just a preference and experience. So anything more than that, it kind of gets confusing when it's too deep. So what you can do is try to look at other things like maybe I could have represented this in a different way so that it will be a lot more efficient, something like that. Or maybe I can get the data in a different way. So yeah, try to think of alternate solutions. All right. All right. So we have run this cell. So the data is available now in our memory. So if we try to run this code, it should run. And there we have it. Okay. So this is Pygo. It's actually um, a very bright library. It's not see here, it's 5, 4, 3, 2, 1. It's some legends here. And you can see how many books there are. So it's from 0 to 120. All right. So we have 120 books for 1 stars, right? And we have more that if I'm talking like I was the owner of the website, so we have uh more 1 star books than 5 star books, right? Um, And I guess in the middle part, we have like somewhere above average. So this is the average. This is where like everything is above average. So yeah, I think this is a good distribution of books in terms of how bookstore goes because you need to cater to um a lot of different readers, right? Not just the ones that are looking for 5 stars, right? What are things that could be considered as 1 star? So uh, it might be self-help books, right? So there's no reason really why you should not have those kinds of books. Maybe you can have a few in stock, but definitely have some those kinds of books because if you don't have that one, you're basically ignoring a certain part of the market. So if you're ignoring a certain part of the market, you're losing sales in that part of the market. So you need to have some kind of a little bit of everything, right? But yeah, so this is how pie chart goes. Oh no, a bar chart, I mean. By the way, Pygol is supposed to be interactive. This is what makes it different compared to uh what was the other one that we're using? Matplotlib and the Seaborn. So if you go to Pygo, right? Pygo documentation, you guys can see it here. It's actually bar chart interactable like this one. So you can put your mouse over it and it will show you the data. You can also even see that it highlights the bar, right, around it. See? Okay. If you want, you can isolate the others and see only the thing that you want. Let's say I'm looking for Chrome. So I want to deselect the others. Okay, I only see the Chrome. See? If I want to select IE, there's IE, there's Firefox, and then there's others. So it's very easy to compare now between the two. So if I see Chrome versus Firefox, so you can see that um, Chrome actually started around 2009 and it's gradually picking up until 2012. And then if we compare that to IE, IE is just going down, right? Because basically IE before was the de facto internet browser, right? And then all the other things are just over here. So these are the Brave, the Opera, the Android browser, the browser used in Mac and Apple. I'm not sure what it's called, but they have their own browser. So this is what the others are for. Basically, it's just too low to be compared, right? Um, so yeah, this is what makes Pygo great. If you put it into something like this one, a website, right? This is where it truly shines. But if you put it here in a Jupyter notebook, then it's just static. You can't really interact with it. So that's a downside of displaying it here. Um, so yeah, that I just wanted to share that. Okay, let's go to the next graph. All right, so we see, sorry. Okay, so what we see here is a distribution by genre and how many books, am I correct? Yeah, how many books there are in that genre. So I think I named the title wrong. There should be book count distribution by genre. It should be book count distribution. So as you can see here, travel is 11, right? We have more books in history, sequential art. What is this? This is women's fiction, fiction, and children's. This is nonfiction. This is default. I don't know what default is, but it's there. This is great. Add a comment and fantasy. We included something that we should not include. See, I think default is also should not be included. We should remove that one on our next. If you ever want to like do this again. Um, okay. What's this? Violet art. Okay. Art. So based on this, you can kind of see how many books we have, right? That we have more books in these categories than the others. So if this can be used to drive decisions for owners or for leaders in the business, right? Because we can say that, okay, since these are the things that we are selling more for now, let's keep the stocks up for these things and then keep the categories that are not really selling as much, just uh a few in stock, right? So that way we can manage our warehouses properly without actually us having to rent more space for more stocks that isn't actually being sold uh, really quickly, right? So we can say that these things here are like after putting it on the shelf after a few days, it's sold, something like that, right? It's there's a quick turnover compared to what's this? I can't actually find this. This is orange. What is orange? Orange is somewhere. Hmm, I think this is new adult. All right. Yeah. Okay. New adult, young adult. Oh, I think it's paranormal. All right. So it's paranormal, psychology, and autobiography. So I think, um, all right. So our window here is actually not enough to show the legend and everything in it. Okay. I think it stops here, somewhere around here, autobiography. So we can't see any more of the other legends. So it's too small. So you need to either break down the graph into two sections so that you can see everything, or find another way. Like look for just maybe you can just segregate the data that you want to see for everything that's above 10 or everything that's above 14 so so that it can fit the graph, right? So you have to adjust this one. What else can we get from this? Mm, I think that's it really for now. So we're just using a very simple bar chart in this case, a horizontal bar chart. And last but not the least is the pie chart. But we have an error, forgotten column. All right. Um, okay, so same problem. See the legend on the left. You can't really see immediately everything, just until up to autobiography. And using a pie chart in this case is not really a good option, right? Because we have too many things to look at, right? Too many colors, and it's kind of like if you were the one that's viewing the data, the target audience, I mean, it would not make sense, right? Because it just looks like scattered all over the place. So yeah, if you're going to use a pie chart, try to limit the data that you're trying to show so that it has more impact to the target audience and that it just makes more sense to people, right? Like maybe these are the number of books that are 18 plus, and then these are the books that are below 18 plus, right? So you can segregate it like that. Or maybe children, teen, adult, young adult. You can do it like that as well. But you have to add other steps here in the segregation of your data to separate it what belongs to children, what belongs to teen, young adult, and adult, right? So you have to do that one. Yeah, I think that's it. So this concludes our second example of web scraping. All right. So again, the site that we are accessing here is a demo of a bookstore, right? An online bookstore. If this was an actual bookstore, there would be another level of difficulty, which is the login, right? Because you're gonna have to add things to your basket and then um buy it, right? So whenever there are those kinds of things, there will be logins. So in your program, you need to incorporate somewhere there um the ability for it to authenticate itself that allows them access to the website, right? So again, if we still have more time, we can do that one. Okay. So we don't actually we can just skip all the other parts. We can just go ahead and see a snippet, right, on how to do it, on how to program something that can just access it using the credentials that you put in your program, right? So your credentials are actually hard coded here. Or for more secure purposes, you can access that data somewhere else. But the point is, your program is allowed now to access the website and its data. Okay. Um, there are other challenges like if the page is a dynamic site, if it's a dynamic site, yep. That means some parts will automatically change the more that you um go over the page. Like if you go down here, the more books will show up, those kinds of sites. Um, what else? Mm, Those are the only things that I can think of right now. Logins, scrolling down. Yeah. Right. And other than that, we have APIs as well and databases when accessing or no, wait, when retrieving data. Okay. It's not, I won't say it's not that common, but usually when you get data, you get it from surveys or data that's already available from other companies, like the one that we got from, if you remember the um, flight plan. Remember that one? The activity that we did. So that was coming from a certain airport, right? So they have the data already. All you have to do is ask for it if you have the credentials for it to get the data. Okay. All right. So I hope you guys learned a lot. Um, yeah, yeah, it's 2:30. Let's have a quick break before we proceed to um, unsupervised learning because it's quite long as well. Oh yeah, I forgot. Let me upload first the the how do I say it? The data set we're gonna use for this activity. So we have the flights data set here, right? Okay. I'll just put it here. By the way, this wrong. I'll just put it here so that you guys can have it ready on your end, download it, and, see it for yourself. Okay. So I'll give you two versions of what I have. So here. So there's a reason for this. There's cars CSV and then cars manually cleared. I'll discuss this one later, why that is. Okay. But the actual thing that we're gonna use is this one originally, and then we're gonna modify it a little bit, and then we're gonna use this one. Okay. So I'm gonna save it. Should be available on your end when you when you log into the LMS. Okay, these two. All right. So let's have a quick break. Let's be back here by 2:50. Oh, no, wait, it's 2:25, maybe 2:45. Okay, somewhere around that time. All right, I'll see you guys in a bit. Have a good one. All right. So we're back. Break is done. Can I get a thumbs up just to confirm that you guys are here? That's one, that's two. How about the others? Three, four. All right. I think that's good enough. Five. Okay. Cool. Thank you. All right. Okay, so I hope you guys downloaded this one. Um, right. I can't seem to open it here. I'll guess. Uh, Excel. There. All right. This is what is inside the cars CSV. Um, so this is the data set that we have, right? And these are the different data that we have. We have company names, car names, we have the engine, car battery, horsepower, total speed, performance. We have uh, car prices, fuel types, seats, and the torque. All right. Um, let's see here. So first we have to um analyze our data, right? Um, so we have all the names here. Um, our car names here have a mix of numbers and letters, right? Engines here are just around 2 to 3 letters usually. Engines, let's see, let's scroll down. A cylinder in line. All right. Okay, so these things, right? When you get your data, try to have it uniform, right? Of course, sometimes it's not going to be in uniform, like this one. So this model actually has two types. It has a 1 liter turbo i3 and a 1.5 liter turbo i4. So there's actually two types. So supposedly there should be um, two rows, but in this case, there's another type here, 999cc and 1498cc. This is for the, what column is this? Battery capacity. Let me freeze the top row. I'll go back to that. Where is it? Okay. Yeah, this one. Here for the horsepower, it's also 80 to 100 HP. Um, that's it. Okay. All the others are basically uniform with whatever's around it, right? So whenever you're trying to collect data, make sure that the columns, the data in the columns are in the same format. All right. So try to avoid having these things. So what do we do with these things? Either you remove them programmatically or you remove them manually. Hence the name of the other data set that I have, cars manually clean. So I manually removed the rows that I did not include that I will not include for uh for my data set, right? That I will plug in later to my algorithm. So yeah, the reason why I did this manually is because when I started to like scan the data, there wasn't really that much. So there's only a few, and I can actually just easily highlight something like this and then delete row. So it's actually pretty fast, pretty quick. All right. Even though there's 1,000 rows of data, um, it's still pretty quick compared to when I do it programmatically, right? Um, it's not the advantage of not doing it programmatically is because you're not really sure the next time that you get a data set, it's going to have the same problem. So you're still going to revise your program, right? Whereas if it just takes just a few minutes, I'd rather do it manually. So uh, there's that. Okay. So I removed, oh no, okay, not really removed, more like put it separately for now because it's different to classify them within the majority of the data that we have. So majority of the data that we have here, um, let's see, have majority of the data have single values like this one, 31,000, the 9,000. So let's take the majority first and then uh, decide later on how are we going to add the data that has multiple variations, right? Like how are we gonna supposed to uh, write them down in these columns. Okay. Like for example, this one, the torque, it's 100 to 140. Why is it not exactly like that? Because if these are industry standards, or if these are what they recorded in the industry during testing, then they should have a set number, right? I mean, there are tolerances, but they should also dictate that it's around 130 Newton meter plus minus 5% tolerance or something like that. It should be like that, right? When it comes to specifications. Prices is dependent also where you're gonna buy them or where who's selling them. So it's best to avoid something like this as well, ranges, because it's not really good. You can maybe use two columns for this. One is worth 12, the other one is worth 15. But since it has similar data, the other columns have similar data. Not really sure. Yeah, it can affect the output a little bit because it can kind of drag it to its direction, whatever that direction is, because there are two instances of that, and the only difference is the car prices. So what if you're using that data, right? The data for horsepower or maybe total speed, but car prices is just neglected, right? Like it's just there, you're not really using it. Then because of the car prices that there are two rows for it, it's dragging the result to that direction, right? So I hope you're imagining it with me. Um, it has more weight because there are two instances of the same thing. You understand? So try to avoid that one. Okay, let's focus on the majority of the data that's similar format. Okay, so I removed rows that have something like this, in their car prices and their torque, in their horsepower. Okay. For the seats, I manually just added them directly. So if I see something like that, I just converted them to arithmetic equivalent. So 2 to 15. I think I removed this one because what kind of car is this 2 to 15? This is a bit to the transit connect. I'm not really sure what kind of car this is. Why does it have 2 to 15 seats? Transit. Is this a bus? Oh, no, wait. I'm not really sure what this is, why it has 2 to 15 seats, but I think I removed this one as well, this entire thing, because I don't know how this is gonna affect my output, right? Um, this one, right? Price ranges. This one, other capacity. So the plus electric motor. So that means there's another one without an electric motor, right? So remove that one. Um, this one as well, horsepower 117 to 148. So as far as I know, when you get like your owner's manual, the specs that is listed there is usually in single digits. And then if there are some tolerances, then, but I guess one option that we can do is to average it, right? So if you have something like this, you get the two and average it, and that will be the new value for that row. But it takes a while, especially if you have to do this programmatically, because this is from text. You have to get the numbers from that text. That involves using regular expressions. Regular expressions are a bit tricky. You have to do regular expressions per that format. So if it's this format, you have that specific regular expression. If it's in this format, it's another different expression. If it's in this format, it's a different thing. So you need one regular expression for each occurrences that is unique, right? So it's harder to do that one programmatically. So it's easier if we just look at it and then um say manually just average it. Okay, I can say easy because it's just 1,000 rows and it's not really that much. But if this was over 100,000 rows, I would not be doing that. I would be using the Python for that one. And I would do it per column. So I would scan this one first for everything that has this kind of uh, format. And then I would use a regular expression to scan the text. That's what the regular expression is for. It scans the text for specific patterns. So the patterns that I'm looking for is one, a number, a comma, and then three numbers, right? This one, right? That's the format that it has. So I'm looking for two numbers that are like that, get them, right? Save them in the variable, and then get the average of them both. And that will be the new value for that cell. So it's a bit tricky actually to do it, but it's perfectly doable. It just takes a while. And then you have to go to horsepower, do it all over again, look for all the unique occurrences, and then occurrences where it looks like this, I mean, and then create a regular expression for that one, scan, average, that's it. Um, I'm also not sure if averaging it is the best way because in this sense you're gonna have to like do comparisons with the results. First is you have where all the uh, all the data that have something like this is removed. That's the cars manually clean file that I have. The next thing that you should compare is what if you were using the upper end, which is the higher value ones, 2000, 148, 197, and then compared to another result if you're using the lower value ones, so the 117, the 154, the 1600, and again versus using the average. So I'm sure the data will be somewhat close, but there should be some kind of difference, right? Because I went from, I think, this is this is 1,200. If I remember, it was around 700 when I cleaned it up. So there's around 500 or 400 rows that I deleted. So that has an impact, right? When you put them all together. Okay. What else do we have here? Uh, yeah, performance, same thing. look for that format, especially for something like this, right? So what if what you're looking for is something like this, but in some instances it can be something like this as well, 7.9 to 10.5. So it's a different format because now there's two numbers, dot, and one number, instead of just one number, dot, one number when you're searching for that text, right? Um, yeah, that's it. What else? Mm, Oh, and that doesn't also include the point that you have to convert that from text to number before you can actually process it. So that's another level in your program. Mm, yeah, yeah. Aside from that, yep. Okay, petrol and diesel. So this car, right? As you can see here, is also being separated in the name, right? So actually, it's the one on the left. Um, I'll have the data on the left, and the one on the right, I will have the data on the right as well after the slash. So the only thing that's wrong is this one, the price. So I'm guessing they have the same specs, whether it's petrol or diesel. And for the torque, this is some problem because it's a range, not an exact number. So we can't side for this one. Yeah, same problem as earlier. They're gonna average it, choose the higher number, or they're gonna have to also indicate that in your explanation. Like, um, there were some rows in our data set that have something like this, and we chose the higher number. And you have to give out the reasoning why you chose the higher number, right? So you have to explain those things as well. Um, for seconds. Okay, all right. Adjusted it earlier. Okay. So that's one thing, right? So we removed those pros of the thing. Let me go back now to where's those state this right. Okay, here. Let me open up the cars manually cleaned CSV. I think I can open it up here. Yeah. All right, I can open it in Jupyter. So this is the one. All right. And as you can see, um, we're going to go to the right. So if I scroll down now from this part, okay, observe the data that they have as I go down. So wait, trying to get into, let's go into the other screen. Okay, so as I go down, take a look. So as you can see, it's very uniform, right? Even the units are the same, okay? Right. So this is what I did. Okay. I manually cleaned the data, or I say clean, but I just removed. But technically, you should just separate the data and save it into somewhere else where you can access it later on and use it to further your research, right? Because it's not really that easy to get raw data that is that is true and hard to get. So try to save those data as much as you can. Don't just delete them just because you don't need them. Just put them somewhere else, and maybe you'll find a use for it later. All right. So as you can see, this is the data that we'll be using. even here. So in the battery capacities, the card names, I remove those rows that are kind of confusing. So yeah, for the engines, as long as they have like the same names, like this, I didn't really mind it that much. So I just included it for now. Um, let's see. Yeah, yeah. So this is good. Um, in a way, us manually removing the rows of data is also part of processing the data before actually passing it to our algorithms, right? So yeah, uh, that's it. All right. So now we'll try to go and access it. Let's see. Labs no code. So on the Hmm. Okay, so I want you guys to remember that in supervised learning, the algorithms that we're going to be using are the k-means clustering. We have a hierarchical clustering. We have something called PCA and isolation forest. So we have k-means clustering. We have hierarchical clustering. We have something called PCA. And then the other one is isolation first. So we'll discuss one by one. What they are for, right? And the expected output and usually the appropriate uh, plots we're going to use for each one. So for k-means, this is actually the purpose of this is to group your data into some sort of cluster, right? Cluster one, cluster two. That's going to be the name at first, but then they're going to be identifying it later on as something else, like cluster one or the budget friendly ones, cluster two or the luxury cars, cluster three is to something else, right? That's what K-means clustering is for. Um, And in a way, that's also the kind of output that we're gonna expect. So, for the hierarchical clustering, uh, it's kind of similar to how an HTML tree would look like. So, kind of like a tree structure, or maybe a random forest, if you think about it. Um, so it shows how each car, right, how cars relate to each other in a tree-like structure. So there's only one that we can use for this one type of plot, and that is the dendrogram, like dendrogram. So we're gonna be using that one. PCA is next. So PCA is for reducing two-dimensional data, um, reducing data into two-dimensional data, right? For easy visualization. So uh, yeah, more than that later. And the isolation forest from the name itself, uh, they're kind of isolating anomalies and outliers. So that's what the isolation forest is for. And depending on your research, right, it might be that what you're actually looking for is the one that's isolated instead of the one that's being clustered. So uh, maybe like you're trying to get like how maybe one of the students, right, is very performant or some of the students are very performant, and you kind of isolate who those students are. And then, or maybe what are the data that you have is their habits, maybe. So they will obviously pop up on your plots. So from then on, you can kind of see like what are they doing differently compared to other students that make them more performing or something similar. Right? So yeah, that's the basic solution. Okay, so that's an introduction, a basic introduction of the things that we're looking for. Put it here. This is for unsupervised learning. If you need a review, you can go back to our PowerPoint that we used before. So it's there. I'll be honest, you can download it and study it. All right. So first is we're gonna need something. Of course, we're gonna need pandas. So we're gonna import pandas as PD. Uh, we're gonna need some special functions. So from SK pre-processing. We're gonna import something called label and uh, okay. Next is we're gonna load the data. So we're gonna say this file path. File path is supposed to parse manually only the CSV. I don't think I have it in this folder yet. I think I just parse manually. Just copy it here. Okay, yeah. Hmm. I should be able to access it now without actually using uh just just calling it out by name directly. Next is cars. Yeah. Cars DF. So we're gonna convert it into a data frame because we have columns and rows, right? So whenever you have something like a spreadsheet, it's always easier if you convert it in pandas as a data frame. Okay. So data frame and Excel is very, very similar. You can just think of them as something similar. Okay. So PD dot read underscore CSV. We pass here the file path that we have. We can put the encoding here. Encoding is equals to Latin A1. Usually when you download data sets, right? There is a certain instruction subwritten somewhere, like what is the encoding of this data set. So you can just copy what it's written there, or look at it at the pandas documentation and look for the exact word that you should put here for that kind of encoding. So Latin one, you put Latin one here. Um, we'll skip the things that we encounter as bad. So bad lines skip. That's okay for now. That's it. So this is just so that it won't terminate prematurely. We'll actually get some kind of help. Besides, we can compare it later on. All right. Um, okay. Let's see. I forgot if I removed the NA. Just to be sure, we'll drop the NAs. Vars underscore DL. Drop NA. In place. We'll set this all to true so that it will return to itself. Uh, okay. So next is what else do we need to do? Hmm, what we did was just remove the rows, right? So uh, these things are still things that we need to process programmatically. And we need to do this with programs because there's a lot of data, right? And yeah, let's just do this one with Python. Although you can do this one also in Excel, you can separate them by spaces and then just get the actual number. But the result will still be the same. Let's just do this one in Python. So let's say we have a definition here. Function mean numeric. So what we'll get is a mean value series. So return td dot to numeric. All right. And for this, numeric, numeric, for this, it needs what? We need to access the series for now and convert it to as types, as type, str. So basically, what this does is we're just making sure that the value on that specific cell is actually converted to string. Uh, because we need to convert this string in order for us to search it, right? It allows us to do some cleanup operations, right? Next is after setting it to type of a string, we're gonna replace all of these things. So replace 0-9 dot regex or the regular expression is true. Yeah. Uh, okay. So what does this actually mean? So we are replacing things that are not digits and decimal points to something that's blank, or it's not even a space, or like it's just removing them. Okay, because this is what we're trying to remove. We're trying to remove the sec, the key per each, the nm, the dollar sign, the commas. We're trying to remove those things. And that's why we have this regular expression. This is what a regular expression looks like. And this actually means here everything, right? That is not a number or a decimal. This is what we're trying to say here at this point. Replace everything into a uh blank space, or yeah. So what would be left with is just a number, but still in text format, right? But here is where this comes in to numeric, because it converts that text, okay? The text, the number that is in text data type right, will be converted into its number equivalent, and then it can now be used for operations. So I forgot we need to put in place here. It's equals to true. Okay. Um, so we need to pass the series here first, right? And in order for us to do that, we need to define first some things and then call out the function afterwards. So we say cars underscore df. We say this one, battery capacity. Okay, so you have to do exactly how it's written there. Otherwise, it's not going to work. Battery capacity. We'll go ahead and call the numeric numeric, and then inside here, we will solve this same thing. Cars DF, uh, DC or battery capacity, and then close it up. Yeah, so basically, we are cleaning up the data and then assign it back to its own column. That's what we're trying to do. Okay. So we need to do the same thing for the other uh, columns, right? So we have horsepower for the HP. We have total speed, right? Because it's CCHP, total speed. Total speed, performance. We also have car prices, the dollar, fuel type. No, not fuel type. This one, torque. Fuel type is just regular text. So those are the columns that we need to clean up. All right. So we're gonna do the same thing here and then just complete it. Okay. So just bear with me here at this point. Horse power. And then this is clean underscore numeric. Cars underscore GF. This is source. Next is the total speed. Cars underscore DF. Total speed. Total speed is equals to numeric. Cars underscore DF. And then of course, so uh, total power, total speed. Okay. The next one is cars underscore DF. This is total speed. That's the most part. Total speed, it's performance. 0 to 100 kmh. Path spaces. So we have here performance of 0 to 100. 3M. Colors underscore DF. Uh, total, total, total speed. Oh, okay.
Dito na lang doon. Balik ka na. Ade. Dito na lang doon. Ayun.
Right, next part is performance 0. Underscore H. And then underscore DF. Um, performance. Underscore H. There, right? Next one is car prices at work. Okay. So we have cars, yeah, cars prices. Number. Wait, no, web browsers. This is, and then this is work. That's it. Um, After clearing those data up, Turk is the last one. We need to drop any again, but this time we're going to use a subset attribute. And I'm going to say subset equals to open parentheses. We have these things here. All right. So basically what we're doing here is manually declaring again each column that we modified with to drop any new NAs that might have happened. That's what we're trying to do. Okay. Uh, that's the electronic source, power, so as tools, speed. I'll just go ahead and copy this one. It's too long. Any horsepower, total speed, says performance. Well, guys, I had trouble trying to read properly. So let's cabbage. I'm checking this one. It's car prices. So cars prices. Was it cars prices or car prices? Oh, here. Cars prices or with an S. Cars prices. Let's see. All right, so we have cars prices, and the last one is work. And then set in place to true, right? So remember to scroll to the right at this point to see the whole code. It's quite long. Like, let's see if we're missing anything here. The next thing that we're gonna do is modify the data that is text, only text. So things like this one, for example, petrol. Petrol, let's go down. Should be another data type here. Wait, there's none. So it's all petrol. Let's look for something else. All right. So let's use the label encoder. All right. Again, the purpose of this, of the label encoder, is to actually, let's see, it's to convert, convert text like this one in line 4, uh, twin turbo, right? These things cannot be used directly in the algorithm because they are strings. What we need to do is use something like the label encoder. The other alternative for this one that is also within sklearn is one hot encoder. Now the two actually do the same thing, but uh they have a slight difference. Okay, but the main point is that they will transform the text into numbers, right? So let's say number one will represent in line 4. Number two will represent 5 liters V8. Uh, yeah, so if you continue and proceed to all the other unique engine types, you will give them their proper number. Now, in this way, you can kind of see, right, the relationship between data based on their engine type. And this is also very helpful because when it comes to clustering, right, you can kind of get all the different kinds of engines also that belong to that certain cluster. Uh, so it's a big help, right, using those kinds of modules in our program. So that's what we have here. We're going to use that one encoder. This equals to label encoded. We're going to create a for loop for column in mm, company names, right? Company names. You can change that one to number. So it's company names, cars names, engines, and then the other one is fuel types, all right? Even though there's just one. Let's add it here. So that's company names. Company names. We have cars names. We have engines, and then we have fuel types. Fuel types. Mm-hmm. The Y here. So cars underscore DF, depending on that column, cars DF column. We will now go to encoder. We'll pass it to the encoder and then use the fit underscore transforms dataset. I know dataset, the methoding. Cars underscore df, pass in the column, and then use the as type again. Like before, we can convert every part, right? Every value that ever uh, passes here into text. So RCW as type string. What? Okay. Mm, so, so if we print out now something like clean data set, uh, and then print parse underscore df dot head. So we'll just take a look at the first head. We can also, if you guys want, compare it to the first one before actually cleaning it, but I guess it's unnecessary. Okay. So again, That's what the label encoder is for. It converts text into numbers that represent uh, them. Okay. All right. Okay. Let's give this one a go. Let's try it. Right. So I did make some mistakes. Closing parentheses, they have match line 21. Closing parentheses does not match. Okay, forgot the bracket. Does that much parentheses on line 23? These things, we got line 22, and seems I've forgotten a lot of things. Okay, 25, unmatched bracket. And to the front. Getting right. Line 18. The best. 39 in place. Yeah, guys, just a moment. Mac. Four. So that's a space. Okay. So counting horsepower. Let me see. Horsepower. All right. Thank you, sir. I did not see that. Um, in place. Let's see. Buildings. What I think the turning one. Place. Two. On reading this one, there's an error here. It's the error here. Place. Wait, place. Okay. This does not belong here. Too numeric. In place. Uh, it was there's, I think this is the one. Listen, in place. There we go. Performance. In what line? 21. The error is there above key error. Key error. How is this spelled? With a space, without space? Without space. There should be no space here. How many spaces do we have? I think there's a space here. No. Label encoder. Label and label. Label encoder. That's no fit. Transforms. Fit. Was it transform? Not transforms. Fit transform. Company name. Key error again. Company name. Company names is one third. Company names. Is there also space? That that's identifying. Company names, cars, names, and gens, and fuel types. Was it fuel types? All right, finally. All right. So apologies for that one. It took a while, but we got it. So here is our clean data set. Uh, as you can see, we're just using the head, so the first five at the very top of our data. And as you can see, the cars names, the company names, the engines are substituted with their equivalent numbers, right? The highest we can see from the cars names is 641. So makes sense, right? Each one should have been unique. So there should be 641. Engines here shows us that the highest one is 151. So odds are maybe it could be higher in other rows, but for now we can say that there are 151 unique engine types in our data set, and so on and so forth. Uh, so the battery capacity, um, we remove the what's in the battery capacity? Was it the CC? Yeah, the CC. Horsepower, the HP removed. Total speed is the kilometers per hour, right? Total speed, kilometers per hour, and then the performance is kmp, km per hour. This is the acceleration, I think. Um, car prices, we remove the dollar sign, 460,000. 460,000. That's too big. 460,000. Let's go to the top. 460,000. Okay, all right. What's this? Oh, okay, a Rolls Royce. Okay. 460,000. Fuel types. Okay, it's zero because here in our data, what you can see is everything is just one petrol type. So, um, we can't use field type as part of our comparison later on, right? Um, what else? Where was I? Field type seats, right? And at work, we removed the Newton meter. So here's our cleaned uh, data set, all right? And we can actually, let's see, cars, DF, column, bit transform. Okay, so we clean it up. All right, so this is our new look of our cars DF. We can save this one if you want to a file, or you can just proceed directly from here. All right, so that's also an option for us. Right. Okay. So I think we're not missing anything here. Okay. So after this, we can go ahead and proceed to K-needs. K-needs. So we'll separate this one, each one to a different cell. So we'll put K-means in here. This would be for K-means. So we don't need to run this one anymore. We had the data already. All we have to do is just access cars, TF, and it should be good to go. All right. Okay. Let's see. All right. Let's have our last break for the session. Uh, yeah, let's have a quick break. I was losing focus earlier. Um, maybe I'll get this, but I was having trouble looking at the text. All right, let's have a quick break. Let's be back here by around 4:15. That should be enough to rest. Right, that's it. Have a good one. I'll see you in a bit. Right, let's go, guys. Uh, okay. So I guess we only have enough time for K-means, and we'll discuss the other three next week. All right. Okay, so for K-means, I'm just gonna write it out again, like um exactly what we need for it. So we're gonna import pandas as PD. Although it's already inputted at the top, I'm just putting it here so that for context purposes. Uh, from sklearn dot cluster is under cluster. You import k-means. What else? We also import matplotlib dot pyplot as plt. All right, or you can use Pygel, whichever you want. It's really okay. So first is we're gonna select the columns that are for clustering, right? So how do we do that? So we say we're gonna save that one into the variable x, for example. So we're gonna say parse underscore df, select underscore v types, and then include only the following. So float 64. So these are the things with decimals, remember, the data type. And also for int 64 are the integers. So these are the only columns that it will choose from the cars df object that we will use for clustering, all right, for the k-means algorithm. So if we print that one out, print X, that's a capital X. Okay, this is what it would look like. Okay, so as you can see, it's just the battery capacity, horsepower, total speed, performance, prices, and the torque. All right, so those are the um, columns that will be used on. Okay, we need to actually identify each one. So let's tell it that you're looking for the things that are actually numbers. Um, oh no, wait. Yeah, that didn't go through with the label encoder because remember the label encoder changed them into their number equivalent, but they were just text numbers, not number numbers. Okay, so there's a difference. Next is we'll apply k-means here. So, how do you apply k-means? So you apply k-means by calling it. So k-means. And you would need two parameters. So one is the n clusters, clusters. Okay. And we can set this one at the three right now. And then random state is to 42. All right. So the random state, like before, we use this one, right? Is to make sure that the data will be I say this. The output will always be the same as long as the random state is always also the same. Okay, so it won't change just because you ran it again. It will still be the same. The output will stay the same. Okay. Now for the n clusters, right? Or what the n cluster is, this actually means how many groups to form. So you're telling the algorithm, this is the data set, form three groups out of this data set. Okay. So there are some methods out there in order to know what is the correct end clusters. All right. Um, but this can also be like guessed directly based on what data set you have. Okay, so there is the elbow method. we have the silhouette score, we have the domain knowledge, those things. So you can go ahead and search for that one. But basically, you can just put some of this here and you can still see some outlets, right? So I'll put those things here and you can research them um, later on and see the difference on the different n clusters that they will produce, okay? So that would be the elbow method, the silhouette, score, and then the domain knowledge. All right, so those three things are some of the common ways of determining the n clusters, right? So let's see. Okay, so we have k-means now. After that, we fit it to our cars.bs, cars underscore bf. We include, right? So it's gonna pass now to k-means, right? But um, how do we identify what cluster they belong to? So in order for us to do that, we need to create a new column that tells us that that row is for cluster one, cluster two, cluster three. So we need to create a new column, cluster, right? This is k-means dot fit underscore predict. And then we pass in the data set that we already have, which is the one with X, right? After that, it should be done, right? We should have the data set already um, available if we print this one out. So if we say print X again at this point, you should be able to see, no wait, it's not appearing. Oh, no, wait, not X. Cars, yeah, sorry. See? Okay, we have a cluster column now. All right, and all that's left is to plug all this data into our graph. So it's actually that simple when it comes to plugging the data into our algorithms. Okay, so we'll just use a scatter plot for this one. It's one of the best ways to represent k-means, scatter plots. Uh, x dot, I look, let's see, choose this one, 0. Mm, C map is supposed to release um, next label um, X dot owns 0 PLT Y label X dot columns 1, right? PLT dot title. Okay, clustering. Of course, PLT dot show. What else do we need? We need, let's have this one right now. Okay, let's remove label. Sorry, spelling again. All right. So let's see. Yeah. Let's throw some more data. Let's say you want to see the cluster centers. So let's say these are the cluster centers, right? And how to access it? You use pandas, array. You call k-means again, which is already done, right? It has already processed the entire thing. After that, you have access to something called cluster and then centers, right? And then we will say columns equals to x dot columns. Then have some kind of comparison, right? Okay. So now it's making much more sense. So, oh, that's right. Let's start first with the cluster centers. So each row here is a cluster, right? So we said n clusters of three. That's why we see three rows here. Now, um, cluster zero, right? This group groups all the cars that are similar, right? Around this part. Um, Similar to cluster one, right? And cluster two. So it separates all the different cars into three sections. Cluster zero, let's see. Um, oh wait, let's go to cluster one. So for cluster one, we can see something like, let's see. Uh, so these values are the mean values, right, of all the cars that are around that cluster. So if we compare the battery capacity, right? So zero, one, and two, what can we possibly say about this? So horsepower is around 329, 4, and 5. Hmm. I'm not really sure about this. I think I'm missing something. The data is only it's only showing us this one. Why is it only showing us this one? Basically, it's saying this is the cluster zero, cluster one, cluster two, but it's too low. It should be spread out, a little spread out. So whenever you have an output, especially in data science, you should always critique if it makes sense, right? Like, you have to double check and verify if it actually makes sense. So let me analyze it for a while. Cluster reviews to one. Mhm. There's nothing wrong with our data. Mhm. Right. Most of the this one is actually you can just uh it's not really that important at this point. So what I'm trying to understand right now is why is it just like two or three data? Why? Hmm. Let's try using horsepower and capacity, right? Let's try using uh horsepower and speed. Yeah. So this is one, sorry, one, this is two, this is one, this is two, well, still not looking good. What else can we use? Mhm. Right. So I think we need to do something else. Um, if you've noticed, right, we have core prices here. So exponent +4, +6, +7. These are very big prices, right? If we go back to our data set, there are 4 million, 1 million prices. So 1 million, what's the largest one that we could find? There's 18 million. What's this one? Bugatti Noir. So I think that's the reason why our data looks like this. So it's not, it's correct, but in the wrong way. Okay. So remember earlier when I said at the very beginning that when you have two rows of the same type, right? And only like the cash price is different, the result will be pulled towards that direction. And this is kind of what's happening here because we have prices that are too large, 18,000. If you compare that one to our lowest price, which is we have 30,000, we have, let's go for something lower. 20, I saw 20. 27 or 6, I saw it on 6. We have 3, 22. Let's see what else. All right. So, all right. 18, I saw 18 here. 10, there's a 10. So it's getting lower and lower. Uh, and what else? I think that's it. So the point here, that what I'm getting at is our data is there are extremes in our data, right? There's something that's too expensive, and then something else that's too cheap. In this context, I mean. So what we need to do in situations like these is we need to normalize the data. So normalizing the data is you're balancing the scales between what is too high and what is too low so that their impact on the algorithm is the same. All right. Their weight is the same. So your output won't be dragged to that direction just because you have a price that is too big, too high. Or in vice versa, you have a price that is very, very low, the output will be dragged towards that direction as well. That's why I said earlier that it looks weird. The output looks weird. It's kind of like it's skewed towards the cheaper ones here on the bottom and very few ones on the top. Even after I change the columns and the rows, it, um, how do I say this? It doesn't look right. So we need to add something else here in between so that we can make it normal. So let's say we have something like, let's put something called scalar here. Oh wait, we need to import it first. Um, okay, so from scalar dot preprocessing import standard scalar. And then print X, I think we can remove this one right now. We'll put scalar here is equals to standard scalar, all right? And then X. So X earlier, after separating all the numeric columns, scalar dot fit underscore transform X. All right. Scalar dot fit transform X. So this is the new thing that we should use. instead of just x. So we put x scaled at this point. All right. What else do we? Um, hmm, hmm, predict. Okay. Okay. Ah, there we go. Okay. Now it looks better than earlier. Um, cluster centers. Let's change this one. Um, it should be original is equals to scalar inverse transform k-means dot cluster underscore centers. Okay. The reason for this is because this is in the wrong units. That's wrong. So what we need to do is use this one, cluster original, and pass this one here instead of k-means cluster centers. It became like this because of the standard scalar. That's what the standard scalar does. It kind of reverses the whole thing in order to normalize the data. Okay, so if you're using standard scalar, you have to use inverse transform on your cluster centers for k-means, or yeah, in general, if you were trying to normalize data, um, at some point when you're at the output, you're gonna have to inverse it in order to get the correct values. So if you run this one again, there we have. Okay, there we go. Those are the data that I'm looking for, right? So let's see. Um, okay, so three clusters, the same as earlier. Three colors, that's for the Viridis CMAP. Okay, so CMAP is just for the color. The X that I look is just the indication that we're gonna select all the rows and then column zero, all the rows and then column one, and then pass them as the XY label here, and then point them on the graph here. And this is what we have. As you can see, the separated beautifully into three colors. So this is cluster zero, cluster one, and cluster two. All right. How do I know that? I'm just reading it around where they are. So 1725. So it's around here, 1725, which is around the center of the cluster zero. So you can do that kind of estimation. But yeah. So what can we get from this, right? How do we interpret this one? So we'll go deeper into how to interpret this one maybe next week. But for now, I think we'll just have to be satisfied with this. We have the means, right? I'll explain this one, what these things mean next week and how they impact our classification of each cluster. All right. And this can actually help out a lot in um, identifying the car type that you have, or you know, depending on what these cars are for. We just have the data for the cars. We don't know if these things are for sale, or maybe they're in the scrapyard. We don't know. We just have this data. So uh, we'll just have, we'll just base it on the data that we have. Okay, maybe we'll not assume anything about where this came from for now. It's just cars, data for cars. Um, yeah, so that's it for now. So this is a good result compared to earlier. Yeah, I think this is a good output. All right, that's the end for this session. Next week, we'll continue with the explanation for this and the other unsupervised learning methods. And of course, if we still have extra time, more examples on the other parts of web scraping that we did not tackle on. Okay? All right. So as usual, I will upload the recording, this file, as soon as I can. Um, Let me see how many sessions do we have left. So for me, I have one more session left with you guys. That's next week. And then there's one more extra session left with Sir Wawa. That will be session 11. So it's more focused on what is currently being used in the industry right now for data science. All right. So it's not just Python, it's not just Jupyter Notebook. There are other programs out there, apps that they use to actually implement data science uh, quickly. So one of those is Power BI. I'm sure I don't know if you've heard of it, Power BI. There are some online alternatives like forgot the name. I haven't really used that one. So I have experience with Power BI. Um, so the good thing about that is because data science came or is used a lot together with Python, right? Learning Python here in this course and also for Jupyter Notebook means that you can directly apply this one to Power BI and to other apps out there. Because from what I know, they also use Python as the underlying programming language. So anytime that you will encounter like you need a customized output, which is almost always going to be that way. um, it's not gonna, aside from basic things, they can't, Power BI and those kind of apps can't really provide very specific outputs. So you have to manually code them in the app itself. And they actually allow that one. Um, but yeah, so this is a good like foundation for you guys so that you won't actually have to be afraid to explore that one on your own when you reach that point. But yeah, so in total, two more sessions. One more for me and one more for Sir Wyatt. Okay, so I hope that answers your question, Sir Vince. Anyone else? All right. So I'll take that as a no. Okay. So that's the end of our session. I'll see you guys next week. Have a great weekend and goodbye.